Somebody will need it later. Okay. So we're going to start really simple with the circle here and talk about angles in degrees, okay? Easy peasy, right? So we know this is 0 degrees. What's up here at the top where the y-axis is? How many degrees is that? 90. Over here, the straight line is 180 degrees, right? And then there's 270. And then when I go full circle, it's 360 degrees. No big deal, right? Colin, are you with us?
Yeah.
Mm-hmm. So hopefully you understand that there's a bunch of angles in between 0 and 90, right? 30, 35, 36, all the angles exist here. We're just not going to write them all out because it's just too much, right? So that's true. This is the positive angles. Now, remember, positive angles go counterclockwise. Negative angles. Let's talk through the negative angles real quick. If I'm going this direction, this would be, it's 0 degrees. It's the same location. But then this becomes negative 90, doesn't it? And then what about 180? It's just negative 180 because I'm going the opposite direction. And then this is negative 270. So far, so good? All right. Nothing new there. We've been doing that for a couple days. Now, let's look at this one. We're going to do this in radians. Radian is another measurement of angles that we use in trig quite often, actually. So what the heck is a radian? So what you're going to do is take that dental floss that may be in the cubby or the caddy on your desk or on your desk. Take the dental floss, and what I need you to do is measure off a piece of dental floss using the scissors that is the length of the radius. You remember what a radius is? This is your radius. So take the dental floss and measure off this length right here, and then I'll come back in just a second and show you what to do. Just the length of the radius, not the whole diameter, just the radius. You're going to take that little sliver, that piece of radius, and you're going to take it around the circumference of the circle. You're going to bend it around the edge, okay? So it's going to look like this. You're going to put it around the edge of the circle like so. And then what I want you to do is use your straight edge to then put in a dotted line right where that stopped, from the origin to that location where it stopped. Once you got that one marked, take your piece of dental floss and measure from that place you stopped. Keep going around the circle. That's probably too far. And you're going to work your way around the circle, measuring out this length around the circle. So you end up with something that looks like that. Now yours may not be as colorful, but that's okay. It should stop right above it, just a smidge. Just a smidge. All right, got it? All right, so what we have here, this measurement from the origin, if I took an angle and went from here to my dotted line, this angle measurement is called 1 radian. 1 radian, okay? So essentially the radian is the length of a radius along the arc of the circle. So then we just count. We go around the circle and count radians. So if this is 1 radian, over here is 2 radians. And you can abbreviate RAD. That's legal. You can do that. And then there's 3 radians right here. Should land just above your x-axis. I know we're just messing with dental floss, and sometimes it gets off. It's okay. 4 radians, 5 radians, 6 radians. So that is what a radian is. So let's define it down at the bottom of the page real quick. 1 radian is the angle created when the intercepted arc length equals the radius. The angle created when the intercepted arc length equals the radius. All right, got that? Now, if you look back up here, how many degrees do you think a radian is? Looks around 60, doesn't it? Ish. So if you had 60, we go with 60, this would be 60, 120, 180. It would land all the way to 180, right? So it has to be a little bit less than 60, but you're in the ballpark. And actually what it comes out to like 58.6 or something. It's really, really close. So good eye on that. So that comes out to like 58.6 degrees. Not that you ever have to know that, but that kind of gives you an idea, a visual idea of where it falls. Alrighty? Because we're used to degrees. That's something we're comfortable with. Now, radians can be written like this or in terms of pi. In fact, we use them in terms of pi more often in this class, so you'll get used to this. So let's stop and think for a moment. We're going to look at this one, and we're going to call this our unit circle. This is the first time you've seen our unit circle. And what we mean by that is 1 length. And that just means the radius of our circle is equal to 1, to keep it simple. All right? Now, do you remember what circumference is from geometry? Yeah, it's just the perimeter of a circle. That's what circumference is. So the formula for circumference was 2 pi r. Not asking you to know that. I'm just showing you where we're going here, okay? If the radius is 1, that means the whole circumference is 2 pi, isn't it? So if I go 1 full revolution instead of 360 degrees, it's 2 pi. We good? Okay, so on this circle, I'm going to put my radians in pi format. So this is 0 radians, and then it goes to 2 pi for a full revolution. Now let's work backwards here. If a full revolution is 2 pi, what's half a revolution? It's just pi, isn't it? And what's half a half? If 1/2 is pi, then half of that is pi. It's 1/2 pi, isn't it? So we would say pi over 2. And then what do you suppose goes down at the bottom? 3 pi over 2. 3 pi over 2. So it's 1.5 pi's, right? So 3 pi over 2 goes down here. Now, how does that connect back to this business? Well, notice for a second that when we measured our radians, it took a little bit more than 3 radians to get all the way to the negative x-axis, didn't it? What number do you know that's a little bit more than 3? Pi. 3 is 3.14, isn't it? Isn't pi 3.14? Isn't that what we have here? 3.14. Boom. So sometimes you will see it in radians. Sometimes you will see it with the pi symbol. So this would be 3.14 radians. If I cut that in half, pi over 2 is 1.57 radians. These are, you'll eventually know these, but it's not urgent to know this, okay? If I go another half a pi, this comes out to 4.71 radians. And then 2 pi is 6.28 radians, which if I go back to my picture, when I hit 6 radians, I still had some space to go before I hit the full revolution, so that's the 0.28 part. All right? This is all new. This is all new stuff for you, so you may be like, what is going on? That's okay. We're building the logic here for where we're going. Everybody okay so far? Following? All righty. Moving on to the next page. Now, we're going to take the circle, and we're going to break this first one up into 6ths, actually 12ths. So we're going to start with, where is pi located? Do you remember? If this is 0, where was pi? It is over here, where 180 degrees is, right? Mm-hmm. All right. I need to break that pi, the half circle, into 6 pieces. So what you're going to do, you're going to end up kind of ballparking it. I'm not going to ask you to use a protractor. So think about it. If pi is the same place as 180, and I divide 180 by 6, what do I get? 30. So I'm doing 30-degree increments, basically. So if I do 30, it's kind of down in here. I'm going to take my straight edge across the whole circle, kind of does both the bottom and the top all at once for me. So it looks like that, okay? And then carry it across. Keep going. The y-axis actually serves as one of your landmarks, even though it's an axis, it's okay. And as does the x-axis. It's not perfect, but you get the idea. All right. All right, do you visually see that if this is a whole pi, I've split it into 6 pieces now? Okay, so we're just going to do fractions. We're going to count in fractions, and it's okay. We're going to start here. This is 1/6 of a pi, 2/6 of a pi, 3/6 of a pi, 4/6 of a pi, 5/6 of a pi, 6/6 of a pi. Huh, doesn't that reduce it as pi? It sure does. I'll let you guys catch up for a second. Okay, if I keep going, I now have 7/6 of pi, 8/6 of pi, 9/6 of pi, 10/6 of pi, 11/6 of pi. And if I go all the way, this would be 12/6 of pi, which we know is also known as 2 pi. Now, can we reduce some of these fractions? Yes, so let's do that. Okay, pi over 6 doesn't reduce, but this one does. This one becomes what, pi over 3? What about 3 pi over 6? That becomes pi over 2. We already knew that was where it should be, right? 4 pi over 6, 2 pi over 3 is how it reduces. 5 pi over 6 doesn't reduce, but we know 6 pi over 6 reduces to our good old pi. 7 pi over 6 is good to go. This one, 4 pi over 3. 9 pi over 6 is going to reduce to 3 pi over 2, which we already knew that. 10 pi is going to be 5 pi over 3. 11 pi over 6 doesn't go anywhere, and this reduces to 2 pi. Now, before we jump further, I just want to point out for you, we've broken it into 6, but we also broke it into thirds. Do you see that when we reduced? So this is a 6th. This one kept the 6th. This one kept the 6th denominator, and this one did. The other ones, look, this became a third, a fraction of a third, a third, a third, a third. So if I counted by thirds, I'd have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Isn't that great how math made it all happen in one swoop? It's all there. And then halves, those are just your axes, right? That's just pi over 2, 1, pi, 3 pi over 2, and there it is. So you have all of this. Now, why are we doing this? Because you're going to have to eventually memorize this. But I promise you, it's not going to be as bad as what we're doing today. Because today, I'm just kind of helping you see where did these come from. There are patterns to this, and maybe you'll see them as we keep doing this over and over. You'll start to see the patterns and helps you memorize it. Because there is going to be coming a memory test where you have to memorize the whole thing with some extra stuff on it than just this. You got to be able to spit it out on paper within 5 minutes. But you're going to do it. Y'all going to be down to less than 2 minutes. I know you are, because I'm going to show you the tricks. Okay? Now, let's come over here and let's do this with fourths of a pi. All right, we're going to start where we started before. If we know pi is over here, and we know pi over 2 is up here, so I've already broken this pi into 2 parts. I need to break it into 4, so I'm just going to put in those diagonals. So we know down here is 3 pi over 2, and this is 2 pi. All right. Do you see the 4 pieces across the top? All right, so let's count them. This first one is 1/4 of a pi. The next one is 2/4 of a pi, but that's the same as 1/2, isn't it? So it's already labeled. Great. Next one is 3/4 of a pi. And then 4/4 of pi is what we know as pi. Then we go 5/4 of pi. 6/4 of pi is already reduced as 3 over 2. And then 7/4 of pi. Not so bad, is it? All right, we good? So, you're not memorizing this yet. We'll get into those patterns in the days to come. But right now, what I need you to be able to do is take these, definitely use this to your advantage, and determine the quadrant where the angle lies. That's all you got to decide. All right? So let's look at this. 5 pi over 6. Okay? 5 pi over 6, we have it in this one here. It's just smaller, just slightly smaller than a whole pi, so that puts it in quadrant 2. Yeah? So that would put it in quadrant 2. Now, what about negative 5 pi over 3? So the negative is like, wait a minute, we didn't do this in negatives, did we? So here's your shortcut, peeps. Find positive 5 pi over 3. Do we have that? It's right over here in quadrant 4. Do you see it? So to make it negative, just hamburger fold it over, and that puts it in quadrant 1 because of the negative. Okay, quadrant 1. Look at this one. 5 pi over 12. Do we have that? And it's negative. We don't have 5 pi over 12, do we? Dang it. What do we do? Okay, so let's use some logic. Is it, okay, yeah, think about this. Is it less than a pi? Yes. Is it less than half a pi? Because half a pi would be 6 pi over 12, right? It's less than even half a pi. So if a positive less than half a pi falls in quadrant 1, to make it negative, I just fold it down and know it's going to land in quadrant 2. I mean 4, not 2, 4. Yeah, okay? 3 pi over 4? Where's that? 2. Oh, look at number 5. We put it back in the number form of radians. Negative 1 radian. Do you remember? Do you remember where 1 radian would fall? When we first did a positive 1 radian would put us in quadrant 1, right? So fold it over. That puts it in quadrant 4. Okay? Negative 3.5 radians. Think in positive terms for a moment. Remember, 180 degrees is 3.14 pi, right? So 3.5 pi would put us in quadrant 3 if it was positive. Just fold it over and it lands in quadrant 2. Ooh, 7 pi, or 7 radians. How many radians is a full circle? 6.28. So where would 7 land us? Quadrant 1. Negative 11 pi over 6. Positive 11 pi over 6 is over here in quadrant 4. Fold it over. We're back into quadrant 1. .25 radians. Quadrant 2, remember? And negative 2 pi over 3. Well, where's positive 2 pi over 3 is in quadrant 2. Fold it over. We're now in quadrant 3. We all right? So far, so good? Notice for a second with me that when they give you radians, they don't always put RAD. But they will never, ever put a degree mark. So it's going to be really important as we're moving forward, if your answer is in degrees, that you put the degree mark. Because if you don't, it's assumed to be a radian. All right? And now you can see the difference. They're very different. So just food for thought. Now, sketching in standard position. I'm going to get you started, and then we're going to go from there. All right? So here's my quadrant. What did standard position mean? Do you remember? Origin is origin is my vertex. Standard position means the angle starts in the positive x-axis. Now, 3 pi over 2. Where did that land? Negative y. So I'm going to draw my arrow in the positive direction and indicate where that angle landed. All right? All right, I want you to try the next, 7? I'm going to blank out my screen so you can't see it. I'm going to put the key up here, but I want you to try them. See how you do. Okie doke. Questions before I turn you loose? No? All right. Try it out.
element where you have to do like a swirly thing.
Yeah. You do have to show all the swirls to indicate the multiple revolutions going on. Otherwise, it may only be one pi, right? Yep. All right, that's what you need to be able to do after today's lesson is identify the quadrant that these angles are going to land in. The video tonight is going to teach you how to numerically convert a radian to a degree and vice versa. And do the coterminals and all the things that we've done with degrees we're going to do with radians. Alrighty? So